Let's talk now about times when deposition occurs outside of the stream channel, but still occurs within the stream or river valley. And the only place this typically occurs is where we get these wider valleys being formed. So in this case here, the one edge of the valley would be over here, and the other edge of the valley would be over here. And we would expect this as we move closer to ultimate base level, down towards the ocean. And we get this pattern where the rivers are moving back and forth in these curves instead of cutting straight down into a V-shaped valley. So we get these wide valleys being formed. These valleys have something that is called a floodplain, and this is the area from kind of the base of the valley on one side to the base of the valley on the other side, where everything is pretty flat in between. So typically, on a typical day, the river would just stay in its channel and flow along the area shown in blue here. But if there's a heavy storm event, this entire floodplain could be the area where the river is flowing through. The water is just trying to move as much water, the valley is trying to move as much water through as possible, as quickly as possible, and the entire floodplain could be flooded, which is why it is called a floodplain. So why does it stay within this channel most of the time if it's so flat in this area? Well, it kind of has these little bumps on either side of the river channel that are called levees, L-E-V-E-E-S. And they're what's holding the river in place. So if we look at a levee, and once again, this would be down in an area maybe in Louisiana or Mississippi, some places close to ultimate base level for the Mississippi River. We do get these levees developed. Here's the river channel shown in blue here, and the water level in the river is the top of that blue, that squiggly line at the top. And we can see that in this case here, the floodplains are actually lower than the level of water in the river. The reason they're being held in place is because we have these levees. These levees can be built by the Army Corps of Engineers, but they actually also occur naturally because when this river does flood, it tends to deposit its coarsest material right next to the river, and then finer and finer material gets deposited as we move away from the river. So the coarse material over time tends to build up these natural levees here, which can be hills 5 or 10 feet high, or maybe a little higher than that, and they serve to hold the river in place. Here's an example here. This is the river channel shown here, and sometimes these levees can breach or break, and then the floodplain off to the side of it is flooded. And sometimes these are the highest things around. Roads can be built along these levees here because everything else in this area is flat. And the top of the levee is actually the least likely to be flooded. But if the levee breaches or is breached, B-R-E-A-C-H-E-D, then all of that water that was in the river is now free to flood over the floodplains in this area here. So this would be an example of a breached levee. And this would be an example of just a flooded area, right? The only thing visible that the only land that we're really seeing here is the levees associated with this river. We can see where the water is typically in the river channel in the middle here. And then all of this area would also be covered with water because that is the floodplain. That is the area still within the valley, but the area where the river flows in times of flooding outside of its channel.